Hello everyone, this is Rahman Muhammad Abdul, and today I will be presenting on NLTK for NLP. That's the Natural Language Toolkit for Natural Language Processing. Through this presentation, I'll walk you through what NLP is, how NLTK supports it, its applications, and some practical examples, including text pre-processing, sentiment analysis, and comparisons with other NLP tools. Let's start with the basics. What exactly is NLP? NLP stands for Natural Language Processing, which is a branch of artificial intelligence that allows computers to understand, interpret, and generate human language. When we speak or write, our language is unstructured, full of nonsense, slang, and ambiguity. NLP bridges this gap by turning human language into structured data that machines can process. It combines elements from computer science, linguistics, and machine learning to analyze text, whether it's a chatbot conversation, a voice assistant like Alexa, or even a translation engine like Google Translate. Now that we understand NLP, let's talk about NLTK or the Natural Language Toolkit. NLTK is a Python library built specifically for NLP tasks. It's open source and was designed primarily for teaching and research, making it one of the most popular libraries in the NLP community. It provides a collection of programs, datasets, and tools for working with human language data. Researchers and students use it to handle text processing from tokenization to sentiment analysis. What makes NLTK great is its simplicity. You don't need a high-end GPU or complex setup to get started. Just install it and start experimenting. What is text pre-processing? Before we perform any NLP tasks, we must clean and organize the text. This is called text pre-processing. Raw text is messy. It might contain punctuation, numbers, or symbols that don't add value to analysis. Pre-processing typically includes lowercasing all text for consistency, tokenization, which splits text into words or phrases, stop word removal, where we remove common words like the, is, or, and sometimes stemming or lemmatization, which reduce words to their base forms. This process is crucial because clean text leads to more accurate NLP models. Why this topic? I chose to present NLTK because it's one of the easiest ways to start exploring NLP in Python. Unlike advanced deep learning libraries, NLTK focuses on core language processing concepts, splitting text, tagging words by grammar, or analyzing sentiment. It's perfect for beginners and for demonstration purposes because it's lightweight, runs on almost any system, and comes with over 50 built-in datasets, including WordNet, one of the largest lexical databases for English. So for this presentation, NLTK made it easy to show key NLP steps without worrying about heavy computation. Now let's talk about where NLTK is actually used, because understanding applications makes these concepts much more meaningful. The Natural Language Toolkit isn't just for academic experiments. It has a wide range of real-world applications. Let me highlight some of the most common ones. Number one, sentiment analysis. Probably one of the most popular uses. Businesses analyze social media posts, product reviews, or tweets to understand public opinion. For example, a company like Amazon can use NLTK to determine if customers are satisfied or unhappy by analyzing their feedback. Using the WADA Sentiment Analyzer, NLTK can classify thousands of reviews as positive, neutral, or negative within seconds. Number two, text classification and spam detection. Another application is automatically classifying text into categories. Think about your Gmail inbox. How does it know which emails are spam? Behind the scenes, models trained on features like word frequency and sentiment perform text classification. NLTK helps build such classifiers easily using naive Bayes or decision trees. Number three, chatbots and virtual assistants. NLTK provides fundamental linguistic capabilities, tokenization, parsing, and named entity recognition that can be used to create rule-based chatbots. While modern assistants like Alexa or Siri use deep learning, NLTK can still power small-scale chat systems or educational bots. Information retrieval and summarization. Suppose you have 1,000 documents, NLTK can help extract keywords, summarize content, and even find top clusters. This is especially useful in news aggregation where it can summarize daily headlines automatically. Number 5. Named Entity Recognition NER. NER helps identity names of people, organizations, or locations in text. For instance, given the sentence, Barack Obama was born in Hawaii and served as the US President, NLTK can recognize Barack Obama as a person and Hawaii as a location. This becomes essential in applications like resume parsing or automated journalism. Number 6. Educational and research tools. Lastly, NLTK is an incredible teaching resource. It includes over 50 preloaded corpora like movie reviews, Shakespeare's works, or even linguistic datasets. Teachers use it to help students experiment with language models and learn text analytics fundamentals. In short, NLTK provides the building blocks for many modern NLP systems. Even if production tools later evolve to faster frameworks, the foundation often begins here. Next, let's dive into how NLTK actually works step by step. This part is called the NLTK pipeline, and it's a great way to visualize how raw text becomes useful information. Let's go through the main stages. Step 1, Load and Tokenize. Here, we begin with a simple input sentence like working with a Python and NLTK has really improved my understanding of language technology. This is just plain text, unstructured as it would appear in an email or social media post. And then tokenization, which breaks down the sentence into individual words or tokens. So we get right from the beginning working to the last full stop. Everything is an individual. Why do we do this? Because NLP models can't directly process long sentences. They work best when language is split into smaller units, words or phrases. The next step is removing stop words. These are common words like and, with, my, or, of. that don't add meaning to analysis. After filtering, we get working Python NLTK really improved understanding language technology full stop. This helps us focus only on the most informative parts of the text. Next, we perform part of speech tagging, where each word is labeled with its grammatical role. Working, verb, Python, proper noun, really adverb, etc. This helps identify how words functions in a sentence. Finally, using WADA, which stands for Valence Aware Dictionary and Sentiment Reasoner. NLTK assigns a score representing the emotional tone of the text. Since we incorporated a positive text, our text leans slightly positive overall. If we can see previous metrics from the output, the neg means negative tone, new means neutral tone, pos means positive tone, and the compound varies from -1 to +1. The compound value is especially useful, positive for happy text, negative for sad or angry tone. Here I took a negative text as well to show the difference and also helps me to visualize both the texts. Here the positive value is 0 and negative value is 0.545 and compound value is a negative, which is sad or angry tone. To summarize, each of these steps transforms unstructured human language into structured, meaningful data that can be interpreted or used in machine learning models. One of the most engaging features of NLTK is its ability to visualize linguistic patterns. For example, you can plot word frequency distributions, showing which words appear most often in a dataset, bigram or trigram relationships, which show common word pairs, and sentiment polarity charts to visualize emotional tone across multiple sentences or reviews. For example, here in our text, you can see the comparison of the two text results. You can see the compound values of both the texts. One can easily say that I have used one positive and negative text by bar chart. NLTK comparison with other tools. When we compare NLTK with other NLP tools such as Spacy, TextBlob, or Transformers, each has its strengths. NLTK is best for beginners and academic research, very transparent and educational. Spacy is faster and designed for production scale NLP. TextBlob simplifies sentiment analysis and translation but lacks advanced features. Transformers by Hugging Face bring deep learning to NLP, offering higher accuracy but requiring more computational power. So, NLTK's main advantage lies in its simplicity and teaching value. Despite its usefulness, NLTK has a few limitations. It may miss sarcasm or context due to rule-based sentiment detection. It's relatively slower for large datasets, and it lacks deep contextual understanding compared to modern transformer models. However, it remains a great learning tool for foundational NLP concepts. Looking ahead, NLTK can be combined with newer technologies for more powerful outcomes. Some potential extensions include integrating NLTK with Hugging Face transformers to blend rule-based and deep learning models, applying it to large datasets like IDMB movie reviews or Twitter data for more realistic analysis, exploring multilingual NLP using NLTK with additional language corpora, or building hybrid pipelines where NLTK handles pre-processing and deep learning models perform final analysis. This hybrid approach can provide both speed and interpretability. Conclusion. To conclude, NLTK remains one of the most important libraries in natural language processing education. It gives us the tools to clean, process, and understand text, while teaching the underlying linguistic and algorithmic principles that power AI communication today. Even though newer tools like Spacey or Transformers are faster and more advanced, NLTK's strength lies in its transparency. It helps us truly understand how language data is transformed into machine readable structure. So, NLTK is not just a toolkit, it's a learning bridge between traditional text processing and modern AI driven NLP systems. Thank you all for listening.